You had a great day off yesterday. Today we're going to start chapter 3 by looking at acceleration. So, our goal by the end of class today is that we can describe the motion of an accelerating object using a position time, velocity time, and an acceleration time graph. So, we're going to be looking at 3 different types of graphs here. But before we get into that, we are just going to talk about what acceleration is. So, when we look at acceleration, this is going to be the rate of change of velocity. So basically, whenever velocity changes, we have acceleration. So this could be our velocity changing value or changing sign. So as an introduction to this, we should have looked at the pivot ice puck lab yesterday. So we're going to take a break and look and see what that puck was doing. Pivot. We slid an ice puck down a ramp. And as it slides down, let's play that again. We should see that it is speeding up. So this is different than our previous unit because we are no longer traveling at a constant velocity. Now our velocity is changing as we speed up. Motion of our ice puck and created a position versus time graph. So we should have position measured on our y, meters, time measured in second on our x-axis. And when we graphed the data that we collected, we should have gotten a graph that looked something like this. Okay, so we had a direct square relationship between position and time. So we can see this looks a little bit different than what we looked at in our constant velocity unit. Now we have a curve when we have acceleration. Okay, so we can see from the motion of this graph that our puck is moving in the positive direction as our positions are increasing. Okay, we can also see that our puck speeds up. Okay, so how do we know that our puck speeds up based off of this graph? So if we think back to last unit, we know that the slope of our position time graph is equal to our velocity. So if we look at our velocities or our slopes at certain points in time, we can see that as time goes on, our slopes get steeper and steeper, or they increase in value. And since our slopes increase in value and they get steeper, this tells us our object is speeding up. Okay. So we can tell from this graph that one, it's moving in the positive direction because our positions are increasing, and two, our puck is speeding up because our slopes are getting steeper and steeper, and our slopes tell us our velocity. To predict what the velocity time graph of this motion would look like. So if you think back to last unit, we were always moving at a constant velocity. So we always had horizontal lines. That is not the case in this unit, because if we look back up at our position time graph, we can see that our slopes are changing. So we're not going to be moving with a constant velocity anymore. The first thing we need to look at is, one, what direction are we moving? We can see here that our object is moving in the positive direction. And if we look at all of our slopes from our position time graph, all of our slopes are positive. So that tells us our velocities are also going to be positive. Or in other words, they're above the x-axis. So our object starts at rest. So it starts at a velocity of 0. And as time goes on, our velocities increase. They get more and more positive. So we're going to show that with a nice linear line with a positive slope. We can see that since our object is speeding up, our velocities get further from zero. So our velocities increase as time goes on because our object is speeding up. Okay? So as a refresher, to go from a position time graph to a velocity time graph, here we are looking at our speed. Okay? If we wanted to go the other way, if we think back to last unit, if we wanted to go from velocity to position time, here we would find our area. So remember, our area of a velocity time graph is equal to our displacement, which would then help us make our position time graph. Okay? That we are not moving at a constant velocity, our velocities are increasing or our velocities are changing. Since our velocity changes, that tells us we have acceleration. Okay? And acceleration is the rate of change of our velocity. So if we want to find our acceleration from our velocity time graph, what we're going to do is we are going to find our slope, because that'll tell us the rate that our velocity changes. So if we want to find our slope of our velocity time graph, that'll tell us our acceleration. Okay? So we know time is going to go on our x-axis, measured in seconds, and acceleration is going to go on our y-axis. To find out the units for acceleration, we need to look at the units of our velocity time graph for the slope. Remember, for slope, we do y units over x units. So for our velocity time graph, we have meters per second on our y-axis. We need to divide that by the units on our x-axis, and we find that our units for velocity are going to be meters per second, our units for acceleration are going to be meters per second squared. So how many meters per second is our velocity changing per second? Okay, so if we look at our velocity time graph, we can see this is going to have a positive slope. And if we pick 2 points on that velocity time graph, we're going to have the same slope through those 2 points. So here, instead of having our horizontal line on our velocity time graph, we're going to have our horizontal line on our acceleration time graph. Okay? Because our velocity time graph has a constant slope, or it's changing at a constant rate. Okay? So since our velocity time graph has a positive slope, it's changing at a positive rate, which means our acceleration is positive. Okay? So we know to go from velocity to acceleration, we're going to look at our slope. Okay? If we did want to go the other way, we wanted to go from acceleration to velocity, here the area of our acceleration time graph would equal our change in velocity. Okay, awesome. Something else I want to point out here is notice how our velocity and our acceleration are both positive values. Okay? That tells us that it's speeding up. So when our velocity and acceleration are the same sign, that tells us that we are speeding up. Position versus time graph, that our object is moving the positive direction since our positions are increasing, and that our object is speeding up because our slopes are getting steeper and steeper. We can then use this information in creating our velocity time graph. We show that our object is moving the positive direction by having our velocities be above zero, above that x-axis, and we show that our object is speeding up by having our velocities get further from zero. We can then take this velocity time graph to create our acceleration time graph. Our acceleration is looking at the rate that our velocity is changing. So if we find the slope of our velocity time graph, that'll tell us our acceleration. So since our velocities are increasing at a positive rate, that tells us our acceleration is going to be a constant positive value. Okay? Object was moving in the positive direction and speeding up. What if our object was moving in the positive direction but slowing down? Okay, so this would be like if we push something down the ramp, but it eventually came to a stop. So if we wanted to make our position versus time graph for this motion, position on our y, time in seconds per x. All right, so since we're still moving in a positive direction, that means our position is going to increase. So we're moving in a positive direction, our position increases. However, if we are slowing down, that tells us our velocities are getting smaller. Our velocity is decreasing. And we know we can find our velocity from our position time graph by looking at the slope. So if we want our velocity to decrease, that means we need our slope of our position time graph to also decrease or get less steep. So when we draw our curve here, we're going to draw it so that our slope gets less and less steep as time goes on. So it's flattening out that curve. Okay. If we then wanted to create a velocity time graph for this one, we need to show that we're moving in the positive direction and that we're slowing down. So since we're moving in the positive direction, that tells us all of the slopes of our position time graph or all of our velocities are also positive. So we are going to want to draw this velocity time graph above the x-axis. Okay, so to show that we're moving in a positive direction, we're going to draw our velocity time graph above the x-axis. So here, we can see that we start off with a greater velocity. We start off with a greater slope. However, as time goes on, our velocities get less and less, or get smaller and smaller. Our slopes get less and less steep. So since we are slowing down, that tells us our velocities are decreasing or our velocities are getting closer to zero. So for my velocity time graph then, I'm going to draw a graph where my velocities continuously go down and get closer and closer to zero. When I reach that x-axis, that tells me my object to stop because there my velocity is zero. Okay, so we're above the x-axis because we're moving in the positive direction, but we show that we're slowing down by showing our velocities getting closer to zero. Okay. So then if we wanted to change this, okay, so we know our position time, we know our velocity. Now we just have our acceleration. Remember, we're going to find our acceleration by finding the slope of our velocity time graph. So if we look at our velocity time graph, we can see that our line is sloping downward. So that tells us here we're going to have a negative acceleration. And since we have the same slope at each point, we're going to have the same or a constant acceleration during this whole time frame. So to show that, we'll draw a horizontal line below the x-axis, okay, to show that we're moving with a constant negative acceleration. Notice in this example, our velocity and our acceleration are opposite signs. So all of our velocities are positive, whereas our accelerations are negative, and that tells us we are slowing down. Our position versus time graph, and we want to describe the motion of this object. So if we look at this, we can see that our object starts with a higher position, and as time goes on, our position gets less and less. This tells us that our object is moving in the negative direction. To figure out whether our object is speeding up or slowing down, we need to look at our slopes of different times in this curve. So when we start off, our slope, let me draw that better, is relatively flat, okay? And as time goes on, our slope is going to get steeper and steeper. So our slopes get steeper. This is going to tell us that our velocity is increasing because we find our velocity by looking at our slope. And since our slopes are increasing, our velocity values are also going to increase, which tells us this object is speeding up. So this is an example of an object that's moving in the negative direction and speeding up. When we want to create our velocity time graph from this, okay, this one is going to look a little different. Let me draw this. Since our object is moving in the negative direction, okay, all of our slopes on our position time graph were negative. Okay, so if we look at the slopes that we drew, we can see that they're all going to be negative. That tells us that all of our velocity values are also going to be negative. Okay, so we're moving in the negative direction. Our velocities are all negative values, so our velocity time graph is going to be below the x-axis. So this one is a little different than those previous examples because here our velocity is going to go beneath the x-axis. All right, the other key thing here is we start off with kind of a horizontal slope. That tells us our initial velocity is going to be 0. However, as time goes on, we said we sped up because our slopes get steeper. So if we speed up, that means our velocities are going to get further from 0. So when we draw our velocity time graph, we're going to want to show our velocities are negative because we're moving in the negative direction, but that they are also moving away because we are speeding up. Okay. So we're moving in the negative direction, our velocity time graph is going to be below the x-axis, and since we're speeding up, our velocities are moving away from the x-axis. Our last graph that we need to make then is our acceleration time graph. Okay. Time measured in seconds, and acceleration measured in meters per second squared. All right. So remember, the slope of our velocity time graph is equal to our acceleration. So here, our slope is a constant negative value. Okay, each point has the same slope. So that means on our acceleration time graph, we're going to have a nice horizontal line below the x-axis, showing that we're moving a constant negative acceleration. Okay? So since our slope of our velocity time graph is negative, our accelerations are also going to be negative. Okay? And we can see here that our velocities are negative and our accelerations are negative. Since they're the same sign, we are speeding up. Okay, so if your acceleration and velocities are the same sign, that tells you that you are speeding up. One more type of accelerated motion. So in this example, we are given our velocity time graph first, and we want to predict what our position versus time graph is. So if we look at our velocity time graph, we can see that our velocities are negative. Our velocities are below the x-axis. Since our velocities are negative and they're below the x-axis, that tells us we are moving in the negative direction. Okay, so since our velocity time graph is below the x-axis, that tells us we're moving in the negative direction, and all of our slopes on our position time graph are going to be negative. Okay. The other thing that we can see is that our velocities are getting closer to 0. This tells us that our object is slowing down. Okay, so that means on our position time graph, our slopes are going to get less steep. So we need a way of showing that on our position time graph, we're moving in the negative direction, So our ending position is going to be behind our starting position, and that we're slowing down, or our slopes get less steep. So that means we're going to want to round out this curve so that we end with a horizontal slope or a velocity of 0. So we're going to want to draw here is a curve that looks like this, like our inverse function. Okay, because this shows we're moving in the negative direction. Our positions are decreasing. And as time goes on, our slopes get less and less steep. So that tells us that we are slowing down, because our slope or our velocities get closer and closer to 0, as we saw in this velocity time graph. Okay? So given our velocity time graph, we can predict how our motion, how our object is moving, and what our position versus time graph would look like. Okay? We can also see then what our time graph is going to look like. So remember, our acceleration is equal to the slope of our velocity time graph. Because that's telling us the rate at which our velocity is changing. So if we look at this example, we can see that the slope of our velocity time graph is going to be a constant positive value, because each point is going to have the same slope, and that line has a positive slope. So to show that on our acceleration time graph, we're going to draw a horizontal line to show a constant slope or constant acceleration, and we're going to draw above the x-axis to show that our acceleration or that slope is positive. Here we can see that our velocities are negative, our accelerations are positive. So since we have opposite signs, that tells us our object is slowing down. Okay? So we basically end up with 4 different graph shapes. Moving in the positive direction and speeding up, so our positions are increasing and our velocities are moving further from 0. Moving in the positive direction and slowing down, so again our positions are increasing, but here our slopes are getting less steep and our velocities are getting closer to 0. Moving in the negative direction and speeding up, so here our positions are decreasing, but the slopes or our velocities are getting steeper and steeper. Our velocities move away from the x-axis. And negative direction and slowing down. So here positions are decreasing and our slopes get less steep, to show that our velocities are getting closer to 0. So when you guys are doing these, you kind of need to ask yourselves 2 questions. First, am I moving in the positive or negative direction? Will my velocity time graph be above or below that x-axis? And second, am I speeding up? Will my velocities get further from 0, or am I slowing down? Will my velocities get closer to 0? And then remember, to find your acceleration, you're always just looking at the slope of your velocity time graph. Okay? I hope this helps. Please let us know if you have any questions. Otherwise, have a great day.